Okay, now, so this is one example of reversible reaction, and when the forward reaction become equal to rate of backward reaction, then it is said to be at equilibrium. So if you want to plot this side rate of the reaction and this side time. See, when the time is 0, I mean at the starting point, which reaction will take place? Forward direction will take place. So at the beginning, rate of forward reaction is more, but as the time proceeds, rate of forward going on decreasing like this. This is for rate of forward direction, RF. And initially there will be no backward reaction, so rate of backward reaction is 0, but as the time proceeds, the rate of backward reaction going on increasing, and at a time the rate of forward and rate of backward reaction become same. This is for rate of backward reaction. So when the rate of forward and rate of backward reaction is same, then it is called the equilibrium state for the reaction. Have you got it? So initially rate of forward reaction is more, but as the time proceeds, rate of forward reaction going on decreasing. Initially rate of backward reaction is 0, but as the time proceeds, rate of backward reaction going on increasing, and at a time the rate of forward and rate of backward become same, equal, and in that state the reaction is said to be at equilibrium. Now characteristics of chemical equilibrium. Characteristics of chemical equilibrium. So some character you should know. Number 1, at equilibrium, the concentration means the amount, the concentration of each of the reactants and products. At equilibrium, the concentration of each of the reactants and products becomes constant. This is one character of the chemical equilibrium. I mean, suppose A plus B, it gives C plus D. This is one of the reversible reaction. When the reaction gain the equilibrium state, I mean when the rate of forward, rate of backward becomes same, then at that state, the concentration of A, the concentration of B, the concentration of C, concentration of D will remain same. I mean the concentration of the reactant, concentration of the product become constant. There will be no change when it gain the equilibrium state. So before gaining the equilibrium state, there will be some change of concentration of reactant and product, but after gaining the equilibrium state, the concentration of each of the reactant and each of the product remain same. This is one of the character. Number 2, in equilibrium, the rate of forward direction or forward reaction, the rate of forward reaction is equal to the rate of backward direction or backward reaction, and hence equilibrium is dynamic in nature. Another point, number 3, a chemical equilibrium can be established only when or only if only if none of the products is allowed to escape out or separate out as a solid. See, what about this point? When you carry out a reaction, you know in number of reactions some gases are evolved, in number of reactions some precipitate are formed. So those type of reaction in which some gases are evolved, gases escape out, or those reaction in which some precipitate is produced as a solid, for that type of reaction you cannot establish the chemical equilibrium, because if the container is open, then the gas will goes out. When the gas goes out, that at that moment the backward reaction will not take place. That is why if you want to get the equilibrium state, the container must be closed so that the gas cannot go out, so that the backward reaction should take place. So that is why there are a number of reactions in which some gases are produced. In that type of cases, you have to carry out the reaction in a closed vessel. Otherwise, you don't get the equilibrium. Because suppose A and B react, it produce C and D. Suppose D is a gas, it goes out. When D goes out from the container, then C cannot react with D. Ultimately, you don't get the backward direction. So when you do not get the backward direction, you don't get the equilibrium state. So that is why chemical equilibrium can be established only if none of the product is allowed to escape out or separate out as a solid. Separate out as a solid means if you get some precipitate in a reaction, for that type of reaction also you cannot attain the equilibrium. Number 4, another character, chemical equilibrium can be attained either from the direction of reactant or from the direction of the product. The chemical equilibrium can be attained either from the direction of reactant or from the direction of product. You can attain the equilibrium. And number 5, a catalyst does not alter the state of equilibrium. These are the character of the chemical equilibrium. In a reaction, when you apply catalyst, the catalyst will do not affect the equilibrium state. I mean, equilibrium will remain there. So a catalyst does not alter the state of equilibrium. You know, there are a number of reactions in which catalysts are used, but when a reaction gain the equilibrium state, after gaining the equilibrium state, if you apply some catalyst also, that catalyst cannot apply the state of equilibrium. Why? Because when you apply the catalyst, maybe forward reaction going on increasing. When forward reaction going on increasing, you will get more amount of products. As the amount of products going on increasing, then automatically the backward direction also going on increasing. Ultimately, the amount of reactant also going on increasing. So when you increase the rate of forward direction, automatically the rate of backward direction also going on increasing, and that is why the equilibrium will remain same. So that is why a catalyst does not alter the state of equilibrium. So these are the character or property of the chemical equilibrium. I mean, when the reaction is in equilibrium state. Thank you.